Good afternoon and welcome to today's webinar. My name is Megan D'Souza, Junior Science Manager at ESETalk. Today's webinar on circular economy is the first in a series of 3 that is going to be taking place over the course of the next few months. So we are delighted to kick off this series with a range of exciting presentations from our speakers who will be sharing their expertise and insights on key issues surrounding circular economy practices and workplace safety in recycling industries. Looking ahead, we hope that the upcoming webinars will be just as engaging and informative. In the upcoming months, our second session will focus specifically on plastics recycling, while the third will address recycling of waste, electrical, and electronic equipment. So we look forward to your continued participation and insightful discussions throughout the series. Before we begin, a few brief housekeeping notes. So today's session will run from 4 to 5:30, and we encourage you to post your questions in the chat throughout the presentations, and we will address them towards the end in the dedicated Q&A session. So to set the scene, today's webinar aims to explore how the transition towards a circular economy intersects with occupational safety and health, particularly in recycling processes. So as Europe accelerates circularity ambitions, it is essential that worker protection and exposure assessment remain central to the discussions. We have an excellent lineup of speakers who will guide us through policy context, exposure science, and ongoing research initiatives in this space. So first, we begin with an overview of the circular economy framework. So it is my pleasure to introduce to you Leah Soeteman-Hernández from the RIVM. Leah will provide a foundational introduction to circular economy, outlining key principles, policy drivers, and the broader context that shapes recycling activities across Europe. So Leah, I give the floor to you. You can share your screen and your presentation.
So much, can you hear me?
Yes, we can hear you.
Yes, perfect. Let me just share my screen. Can you see my slides?
Yes.
Okay, perfect. So thank you so much for the invitation. So today, as you mentioned, my goal is to give you a little bit of a background about circularity and closing the loop safely, and how we want to protect workers and recycling and including end of life. So my talk will be more on the basis of giving you a background. So I think the outline of my presentation will be to really start by giving you a little bit of a background, so we are all in the same level playing field about circularity and really understanding the difference between circularity and circular economy. Then I will walk you about what has been changing, what kind of challenges are we going to have while we transition into more circularity, and how do we ensure that we close this loop safely? And what does that mean for worker exposure? What kind of new challenges do we foresee? And then I want to end with some outlook and conclusions. Oh, sorry about that. So let's start with understanding circularity and circular economy. So let's start with circular economy. So circular economy really is an industrial system that is restorative and regenerative by intention and design. So really keep a key aspects of design. It replaces the end of life concept with restoration, shifts towards use of renewable energy, eliminates the use of toxic chemicals, which impair reuse, and aims for the elimination of waste through the superior design of materials.
Excuse me, our speaker just muted.
Sorry, Leah, you seem to be muted.
You're still muted, Leah.
Hello?
Yeah, now
we can hear you.
Now you're muted again.
And now?
Yes, now.
Okay, let me start again. Sorry about that. Perfect. Let me go back. My apologies.
And it also seems that your screen is not sharing anymore.
Okay, let me go back. My apologies. These are all
No worries.
technical difficulties. Okay. And now?
Yeah, perfect.
And if you can't hear me, just let me know, okay? Because I wasn't sure. Somehow I muted myself. So given for the time, I'm just going to go straight away into the presentation. So we're going to start by circular economy, which really focuses on more the industrial system and really moving away from this end of life concept and really going towards restoration and really through superior design. But when we talk about circularity, it's really we talk about the different practical strategies for achieving circular flow. So here we talk about the 10R framework, really specifying the hierarchical levels between R0 and R9. And really, I really want to bring an emphasis to this concept and design cycle and also produce and use cycle. So we're talking about more the practical strategy. So it's important that we understand the differences between circularity and the circular economy. Okay, hopefully I can shift. So what does this mean? So we are currently in this transition towards a circular economy. So right now we are currently in a system that is very economic centric, where that plays with the bigger loop and following by a social sphere, biosphere, and planet. So what this means is that we're currently in a linear economy whose goal really is to deplete, deforest, degrade, and is really net negative. It's growth at all costs. It's mostly in silos. We really focus on material and chemical or product centric, and it's very substitution centric. And I think where we want to go is to really move towards a more sustainable and regenerative approach, where it's more planet centric, and that means that we're looking at circularity, where the strategies that we are thinking about are to rethink, restore, replenish, and really have a contribution. So net positive. We want to do better with less. It's less part-oriented or silos-oriented. We're looking at more ecosystems and this life cycle perspective. Instead of very specific chemical material or product-centric, we're thinking more in services or service-centric, having a bigger reach of the value chain, and it's a system approach. So as we continue in this sort of transition, we really make a plaidoyer for a new mindset in the way we innovate. And we know that this is usually more effective if you start from the innovation process. So we are no longer interested in sort of prevention or remediation. We want to move towards prevention and not remediation. So we want to have these values of do no harm to men and the environment. And I really want to put an extra emphasis, although the presentation is over circularity, but really the importance of design when thinking about closing circularity and closing the loop safely. So the rest of my talk will be focusing on things or hotspots that we should consider as we transition into a circular economy and implications for worker exposure. I think we also need to acknowledge that we are dealing with existing products. So we want to transition from linear to circular, and you see the gray line. So we want to make sure that we develop strategies to go from linear to circular. But at the same time, we want to create some knowledge circle to ensure that new products and are safe, sustainable by design, and that these also transition towards circular. So all the lessons learned from end of life, we want to bring them back to design. So what are the 10 R's of circularity? I won't go through all of them, but I do want to point out through these different strategies, because there's really 3 blocks of categories. You have R0 to R2, which are more focused on narrowing the loop, which main strategy is to minimize the use of products and materials and maintaining value as long as possible. This is followed by R3 and R6, which the biggest strategy is to slow the loop. Really, the goal there is to maintain products and materials at the highest utility. And finally, R7 to R9 is closing the loop to really how do we use materials again when they reach the end of life stage and create further value. So those are the basics for the 10 R's of circularity. So in worker exposure scenarios in end of life, we're really dealing with 5 different workplaces so that I'm going to focus on. The first one is the collection and reverse logistics, followed by sorting and pretreatment, The third one is dismantling and repair, followed by mechanical and chemical recycling, and material recovery and secondary raw material production. So I'm going to walk through each one of these. So first, we're going to start with collection and reverse logistics. So circularity requires new flows of materials going back into the system. And what this means for worker exposure is that you're going to have more exposure on manual handling of mixed waste containing unknown chemical residues, leading to dermal and inhalation exposure. It will mean probably more exposure to aerosols and dust released from damaged products, for instance, powders and coatings, and leachates or spills from containers with residual chemicals during transport or consolidation. So these are things that we need to really take into account while we're thinking about worker exposure scenarios at the end of life. The second is sorting and pretreatment, where circularity requires new business models and operational processes, and including sophisticated sorting. What this means is extra exposure to airborne particulates, mainly from shredding, crushing, or mechanical separation of plastics, composites, or advanced materials. Volatile organic compounds released when mixed waste streams are opened or processed, exposure to legacy chemicals such as flame retardants, PFAS, or heavy metals that are embedded in older products as we're trying to reloop them back, and cross-contamination between waste streams due to insufficient segregation. So these are extra attentions when we're dealing with sorting and pretreatment. Then you have dismantling and repair, and here circularity emphasizes in repair, refurbishment, and remanufacturing. And these activities create exposure scenarios such as the exposure to dust and fibers released when opening casings, cutting components, or removing insulation, chemical residues from adhesives, coatings, lubricants, or cleaning agents, thermal degradation of products when heat tools are used to separate components, and nanomaterial release for advanced coatings or composites during sanding or abrasion. Again, these are extra hotspots that we should be kept in mind as thinking about these new exposures with circularity. Then you have mechanical and chemical recycling because there is a need for resilient future-proof systems, and this includes scaling recycling technologies. And here where we might expect hotspots such as high concentrations of fine particulates during grinding, milling, or pelletsing, thermal decomposition fumes from plastics, elastomers, or composites during melting or extrusion, solvent vapors during recycling process, and catalyst or reagent exposures in advanced recycling of batteries, polymers, or electronics. So, these are extra hotspots. Then when we're talking about material recovery and secondary raw material production, circularity depends on turning the waste into high-quality secondary materials. And hotspots that we need to consider are metal fumes and oxides during the smelting or refining of recovered metals, acid mists and reactive gases in hydrometallurgical processes, residual contaminants in secondary materials that volatilize or become airborne during processing, and unintended reactions when mixed waste streams introduce incompatible chemicals. So these are really just an overview of possible extra exposure scenarios when end of life. So what is the outlook? So I think some cross-cutting exposure drivers linked to circularity include sort of this increased material circulation means more frequent worker contact with used products, a greater heterogeneity of waste streams, which increases uncertainty about chemical content, the always worry about legacy chemicals re-entering the loop and creating unpredictable exposure profiles. New circular business models create new workplaces with new exposure pathways. So these are something we need to keep an eye out. And pressure for efficiency and scale in recycling can intensify exposure if the controls lag behind innovation. So these factors should really be considered as we are looking at these end-of-life and new worker exposure scenarios. I hope that these hotspots can really help regulators design targeted safety requirements for recycling and repair sectors to protect workers, to inform superior design. So, this concept of design cycle and procedure use cycle and safe and sustainable by design. I hope that we can incorporate these as we are redesigning and designing new materials. These hotspots can also support policy alignment between circular economy goals and occupational health standards, and finally guide investments in safer recycling technologies and training for workers in new circular roles.